Okay, hello. Uh, we are getting started in a look at early modern philosophy. And in order to think about early modern philosophy and what's going on within this field, it's very important to understand not just what different philosophers like Locke and Hume and Descartes are saying, but we also want to understand the historical context that they're coming out of and the situations that they're responding to. So, what are we talking about when we talk about early modern philosophy? Well, roughly, the term refers to philosophy being done roughly in this period of 1700 or 1600 to 1800. That is the 17th through 18th centuries. And one thing that we can do when we think about early modern philosophy is think about it as a response to what was going on in Europe at the time. And what I would like to suggest to you is that we can understand part of what's going on in early modern philosophy is a response to shifting authority relationships at the time. Specifically, religious, political, and scientific authorities were being upended in some cases and being reformed and re-understood. So here's what I want to do in this clip. I want to highlight some of the changes that were going on in Europe at the time in the 17th and 18th centuries. And then we're going to look at some philosophical work by somebody famously known as a scientist, that is Galileo. So, by understanding how society and how thinking was changing at the time, it's going to help us to understand why philosophy became interesting and distinctive in the way that it was in the 17th and 18th centuries. So, first thing to note, through politics and religion, here we have Martin Luther. So the main thing to know about Martin Luther for our contexts is that he was a pivotal figure in a schism within the Christian church, right? So this is where we get the division between Protestantism and Catholicism. And this begins when Martin Luther famously nails the 95 Theses to the door at the church in Wittenberg. So this was in 1517. So before early modern philosophy is really getting to work and moving, but we can see this as an important historical precedent that was in the air in Europe at the time. And these different perspectives, Protestantism versus Catholicism, can show up in certain philosophical debates. So for instance, Thomas Hobbes. Hobbes was a Protestant, so not Catholic. Specifically, Hobbes was a Calvinist. Hobbes ended up getting into debates with a Catholic philosopher, Erasmus, about free will. So Protestants, like Hobbes, tended to think that predestination is a way to think about the human being's place in the world, right? So we could think that everything that's ever going to happen to you is predestined, maybe pre-known by God. And because everything you do is determined, being saved, that is going to heaven, is a matter of grace. That is just the good luck of God and how God treated you. Whereas Catholics tend to deny predestination. So they tend to believe that there's a truly open future and that you have free will in this strong sense that for everything that you ever do, you could do or not do that thing, right? Interestingly for Hobbes, even though Hobbes believed in predestination, he tried to make arguments that predestination and free will, or at least free action, choices that you can be held responsible for, are in fact compatible. Of course, we'll get many different philosophical debates that could sort of align on a Catholic versus Protestant dimension. But we can also just think about the idea that we have a different perspective towards religion and a religious authority when we get this split. Part of what we see in Protestantism is this idea that each individual person of faith could have a direct relationship with God, and that it is up to them to figure out how to make meaning out of what they find in the Bible. Whereas that tends to be a bit more mediated within the traditional understanding of Catholicism, that it's up to the priest or the pope to mediate that relationship between God and the person of faith. But we can see that maybe one way we can think about this split between Catholicism and Protestantism is this big idea that Protestantism is leaning in this direction of telling people to work things out for yourself. Don't just take matters of faith on the basis of what you are told by your priest or your pope. We also have upended authority relations when it comes to politics and monarchy, right? So in Europe, we had, for instance, the 30 Years' War. Descartes was involved in that war as a soldier, I understand. Then we get the Peace of Westphalia. But as the 30 Years' War is winding down in Europe, we also get the English Civil War. Basically, people in England fighting over who had the right to be king. The English Civil War, in fact, had a great deal of influence on Hobbes's Leviathan. And for Hobbes, he thought that war needed to be avoided at all costs, and this is why Hobbes favored an absolute monarch. Right. Then we have commonwealths formed, returns to monarchy, and eventually, as we come out of the 17th century, we see England leaning towards a more parliamentarian system, and also a system that's more stably Protestant. And this was the sort of system that Locke ends up favoring. So again, this question of who has authority to rule is becoming a debated question, and it's informing philosophy, right? We might start to notice that it's becoming disputed, that there are certain kings who have divine right to rule over people, and this idea would develop throughout Europe in different ways in this time. Third thing that was changing in a big way was scientific advances. One of our key figures is this fellow right here, Copernicus. The main thing that you can know about Copernicus is Copernicus was one of the earliest figures to advance and defend what we would call a heliocentric theory of the solar system. Whereas before we had what would be called a geocentric view of the solar system. Heliocentric just means sun at the center. Geocentric means earth at the center, right? So we can think about this as a radical idea if your church and your teachers are leading you to believe that even though we have a round earth, that the stars and the sun are rotating around the earth while the earth is a fixed point, right? One thing that this does is it literally says that the earth is one thing among many, rather than, say, the center of the solar system. We might imagine why the church may have condemned Copernicus for this view, partly because it does upend this general picture of treating humanity as the ultimate creation of God, right? Now, Copernicus was condemned by the church. Now, Galileo was associated with this view and gave further evidence for the view that the universe was, or I should say, the solar system was heliocentric rather than geocentric. One of the things that Galileo did was he made advances in telescope technology. And with one of his early telescopes, Galileo was able to see Saturn through his telescope and was able to actually see the moons of Saturn. Now, what's significant about this is that when you see the moons of Saturn, you can realize that there is something other than the Earth having things rotating around it. That is, Saturn has moons rotating around it. Right. So Galileo brought important evidence towards this heliocentric view of the solar system, as opposed to the geocentric view. He was also able to challenge a popular view that had gone unchecked for centuries, or at least that had not been debunked for centuries. This is the idea that the speed of falling is not proportional to the weight of things. Right? People tended to think that if you drop a bowling ball and an apple at the same time, that the bowling ball, because it's heavier, just must fall faster. But if you literally knocked a bowling ball and an apple off a shelf at the very same moment, they would hit the ground at the very same moment if they start at the same height. Right? And because of this, it challenges this view that solid objects have this desire or have forces built into them that suck them down to the center of the earth. Right? This sort of view, the idea that things have a force in them that make them want to go to the ground, and that bigger objects have more of a want to go down to the ground, that's characteristic of what we could call an Aristotelian view of physics. Aristotle, the ancient philosopher from ancient Greece, was heavily influential on how science was done in medieval times and leading up to these scientific advances made by figures like Galileo and Copernicus. Galileo also caught grief from the church for advancing views that seemed to be unfriendly towards the religious perspective. Galileo tended to think that we should do science in a way that was guided by the evidence, and made the claim that biblical texts were not to be taken literally. Right? So Galileo borrowed a saying which says, the Bible does not tell us how the heavens go, that is, the way things are, but instead tells us how to go to heaven. Right? So Galileo was attempting to advance this view that, the Bible is not a good source of information for how nature actually works. In order to figure that out, we should go and study nature. We could think of the Bible, according to Galileo, as more of a moral text rather than a scientific text. One last figure who should be thought of as important in the history of astronomy is Johannes Kepler. Kepler managed to work out a number of mathematical problems associated with the heliocentric theory by postulating that planets' orbits are elliptical, and was also able to mathematically prove that the area swept by the line between the sun and a planet rotating it, or orbiting it, would sweep the same area in any particular amount of time. Which basically means that when a planet gets a little closer to the sun in the ellipse of its orbit, it speeds up. And when it gets further away, it slows down a bit as it moves through a wider part of the ellipse. A couple of other further scientific advances that I think deserve being noted. William Harvey was able to understand how the human body works in ways that people did not understand before, especially in terms of the circulation of blood. Robert Boyle was able to make observations about an inverse relation between volume of a gas and its pressure, right? And through this was able to develop a theory of how matter behaves. So Boyle, much like Galileo, as we'll see, was an advocate for corpuscularianism, which was a precursor to theories of atomism, which replaces a theory of Aristotelian prime matter, which I'll talk about a little bit more in a moment. And of course, this leads us all the way up to Isaac Newton, who made huge advances in physics. For instance, these ideas that gravitation is what explains celestial movements. Newton was also famous for developing the particle theory of light and what we might think of as the three laws of thermodynamics. Inertia, things in motion will stay in motion, things not in motion will not go into motion unless other forces are applied, along with the idea that energy cannot be created or destroyed, and the idea that for actions they will have equal and opposite reactions. So it's in this time that we have all of these massive scientific advancements being made, and it's realized that old Aristotelian style answers to scientific questions are no longer observationally adequate. And it's also the realization that it should ultimately be the work of individual scientists to figure out the nature of reality rather than, say, religious authorities. So we can think about these as these shifts in authority relationships that are emerging in the context of early modern philosophy. So I've given you a short excerpt to look at for today from a piece called The Assayer by Galileo. So, in this time, scientists were sometimes referred to as natural philosophers, right? And this boundary between science and philosophy was not as firm. Now, in The Assayer, Galileo isn't just answering questions about astronomy, but he's trying to answer these questions about the essence of matter, and he's looking at questions about what it means for something to have a property like heat, right? Because the Aristotelians had an answer to this question, right? So Aristotle, for instance, will tell us that different kinds of prime matter have different combinations of heaviness and lightness, hotness and coldness, right? So for each thing, for instance, you could have water, earth, air, and fire, and different things will have different combinations of those to comprise that physical thing. So this pencil, for instance, would seem to have a lot of earth in it, but we might say that there are ways in which maybe it involves certain admixtures of water or air. But if you think of a plant or a dog or a table, we're going to have different intermixtures of these four elements, and we're going to get different behaviors in the objects based on, say, whether they are wet, dry, hot, or cold. We'll also notice that things that are hot and dry tend to move upward. Things that are cold and wet move downward. Also, things that are cold and dry move downward. So it's actually the cold things move down, the hot things move up, right? And this is how we try to explain physics and explain why certain things fall. Well, it's that water has this inherent coldness to it, and cold things want to fall towards the center of the earth. Hot things like air and fire want to rise up towards the heavens, right? But the idea here, we'll notice that hotness and dryness are just inherent internal properties of, certain kinds of prime matter, like air and fire. Right? And Galileo seems to notice that the common view among people is something kind of close to the Aristotelian view. He says that the common view at the time is that heat is an accident. That is, it's a temporary property. Philosophers will say something is an accidental property if it's a property that's had sometimes but not all the time. Right? So for instance, if you are tan at the end of the summer, well, you might say that that is a temporary property of you. You weren't tan at the beginning of the summer, right? So it's something that comes and goes, and we might say, well, there's this essence of heat that can flow into or out of an object. Now, here's Galileo's modern answer. He takes this corpuscularian theory, right? He's going to say that matter is not made of, that is, material things are not made of these 4 prime elements, but instead, all matter is made up of one kind of thing. It's like these little packets of material stuff. These packets of material stuff are going to be called corpuscles. They're little bits of matter, right? And then difference in these things emerge insofar as they are arranged in different ways, right? So you could have differences in things through motion, density, and shapes. So you would say the stuff making up this pencil is not fundamentally different kind of stuff as compared to, say, my dog. Right? Now, how does this give us a different picture of what's really real for Galileo? Well, he's going to suggest this. He says, whenever I conceive of any material or corporeal substance, he says, I'm necessarily constrained to conceive of that substance as bounded and as possessing this or that shape, as large or small in relationship to some other body, as in contact or not in contact with some other body, as being one, many, or few. What I see in this passage is that Galileo is telling us that when you think about a material thing, you can fully describe it. Remember, he's saying that it's bounded and possessing certain kinds of qualities. And the kinds of qualities that he gives us are shape, and as they relate to other things, right? So we might say that this pencil has a certain shape, it has a certain quantity of material packets of matter in it, and it's a certain distance from my hand, it's a certain distance from my face, right? And he's going to say we can describe everything about the pencil in terms of mathematically representing where all of its material parts are. But notice that when we talk about shape and location, density, relation to other objects, he's going to say, look at this. Tastes, odors, colors, etc., so far as their objective existence is concerned, he says, these are nothing but mere names for something that resides exclusively in our sensitive body. Right? So here he's saying, like, look, when we take a scientific perspective on the world, we can talk about the yellowness of this pencil. Well, what is it for something to be yellow? Well, it's just to have a certain arrangement of particles, and that certain arrangement of particles is going to cause light to hit it in a certain way. It's going to reflect out certain parts of the wavelength. It's going to send those wavelengths into your eye and cause some kind of fancy chemical reaction within your eyes that sends a signal to your brain that gives you a certain kind of feeling. Right? And he's basically saying that yellowness is really more about the subjective feeling that resides exclusively in your sensitive body. From a scientific point of view, we could describe this yellow pencil in a way that completely excludes talk about its yellowness, and we could just talk about its particular kinds of shapes and material textures. Now, Galileo gives us a pretty funny example towards the end. He says, think about the fact that ticklishness is more in the eye of the beholder than in the object that tickles the person. So he says a feather, that might tickle you, but we don't say that there's a special tickling essence within the feather, right? And he's going to say, when we take a philosophical point of view about it, we could say a similar thing about colors, flavors, or sounds, right? Sound is just motion in air pressure with certain kinds of vibrations, where we get low sounds for slow vibrations and higher pitch sounds for fast vibrations. But on this view, Galileo says, well, when we think about sound as what you're hearing, a pitch in your ear, he says that's more in you than it is in the moving object or the air. So he even says that if there were no observers, there would no longer be such thing as colors, flavors, or sounds. Now, if there were no observers, there would still be corpuscles, and there would still be numbers of things and shapes of things and certain arrangements and certain relations between each others. But the subjective experience of something like a sound or a flavor or a color, Galileo is going to say that's more in you than in the object. So what is heat really? Well, Galileo says that heat is really just corpuscles in motion, moving our bodies and being distributed in our bodies. Now, he makes some hypotheses which ultimately would not be confirmed by science. He does, for instance, make the claim that heat is and flames are a particular kind of corpuscle that's just a little finer, right? That can interpenetrate other objects. Now, he wasn't really right about that. It seems like flames themselves are not objects, but they're actually chemical reactions and motions that we perceive as a certain kind of thing. But he was on to the general idea that we shouldn't think of heat itself, our experience of heat, as something inherent to the object. Instead, he thinks that it's more our way of experiencing certain kinds of motions in corpuscles. But we can see how this general approach speaks not only to a particular way of thinking about the nature of heat, but we can also see it in the context of taking a scientific point of view on the world and maybe not taking the old Aristotelian line that says, well, there are inherent qualities of things like heat just built right into a certain kind of object that is fire. That really, when we start to think about hotness, it's not really in things, it's more in our experience of them. Now, this idea that hotness or color is not really in an object, this is going to be a recurring idea throughout this course, right? So when we think about the relationship between mind and body, or the nature of reality and how we can know anything about it, well, this perspective, especially about what is really real, is going to come back time and time again. So philosophers like Descartes and Locke, but also Berkeley and Hume, and eventually Kant, are all going to really grapple with these real questions about whether we can think about certain qualities as inherently subjective rather than part of the real objective world. So this perspective that we're seeing from Galileo here is going to be one that we're going to reconsider, see it put in different words, and then sometimes challenged by other philosophers. And again, here we can see that this change in scientific viewpoint is going to then inform a change in the way we think about the world philosophically. So that's just our first little keyhole into how early modern philosophy got its start with these scientific, political, and religious changes in the air. And as we move along, we're going to see ways in which this is going to change our philosophical perspective on the world a great deal. So thanks for listening in this time, and we'll talk again soon. Thanks.